In today's session, obviously, we're looking at covering, this particular topic, which is estimation and approximation, which is I would say, a fairly easy topic, but I'm going to go into some very basics of it so that most of us are able to understand what it means by, estimation. In today's session, obviously, we're looking at covering, this particular topic. That was a bit of recording.
Sorry, is there possibility to get ID, the Zoom ID, so I can log in on my laptop instead of the link, please?
Yes, you can definitely. Give me 1 second. I'll share that with you. Here we go. I've just sent it to you on WhatsApp.
All right. Thank you very much.
So we'll make a start now. I'm going to start off now. I think the others who join can actually look at watching the recorded session, so not a problem. So are you able to see the screen and hear me okay? All right, okay, that's great. So today's session that we are going to look at, is one of the topics in the topic list that we want to cover, and that is essentially what is called estimation and approximation. What I want to do is very quickly show this on the Moodle first, because it'll be good to get a bit of an idea in terms of where this is on the Moodle platform. Now, essentially, if you go into and log in and you go into NCFE courses, click on maths, you'll be able to see there is a huge topic list. There are, I think, about 29 topics in maths that we need to look at. Now, when you do give the exam, it's a 2-hour exam, and first half an hour of that exam is a non-calculator based section. And then the next 1.5 hours that you do in the exam online is a section in which you can actually, the part of that exam, you can use actually a scientific calculator. Now, you're not looking at obviously scoring 100%, but the minimum pass mark for functional skills, because it's at level 2, it is equal to a GCSE grade C or grade 4 or 5. The minimum pass mark that you would need to score in the exam would be 55%. Now, because there are lots of topics, what I normally recommend learners to do is basically go and be familiar with at least 20 of the 29 topics, because sometimes I find that learners find it difficult to maybe look at topics like 2D shapes, 3D shapes, angles, or maybe diagrams, or areas and perimeter and volume and things like that. So my session here would be to look at zeroing down on 20 topics that you feel you're going to be absolutely confident with in terms of when you sit the exam. Now, the reason I say this is because if you are familiar with 20 topics, you're going to be scoring anywhere between 60 to 65%. And the minimum pass mark being 55%, that would take you over the finishing line and you'll be able to receive the certification. So last week we had done positive and negative numbers. Today we are doing estimation and approximation. Now in the series of these sessions that we are going to plan, we are going to cover, my aim is to cover the simpler topics first. So I'm going to look at covering multiple number of these topics in these sessions, and but the idea would be to try and cover the topics which we use in our day-to-day lives, and something that we are absolutely familiar with, does not require any knowledge, just a bit of common sense, and they would be easier to, let's say, complete and obviously get 100% marks on when you get them in the exam. So this particular topic is estimation and approximation that we are looking at. So when you click on this arrow, it will show you a couple of things which are already uploaded here. This is the presentation that I'm going to be running through, which is a brief outline of what we need to cover in this particular topic. And underneath that presentation, if I go back, you're going to see that there are different knowledge check exercises. So there are some activities that are put, and these activities also have answers. And there's a Word document which has also been put as an activity that you can complete. And then obviously, send this across for the purposes of marking and checking. Although I can also upload answers here, and you can download the document and obviously at some stage then go through this, attempt it to, let's say, understand the topic, and make sure that you are 100% sure on this, and then you can go and look at answers and check the paper yourself. Most of the activities that you will see essentially will always have a number of pages. So the first page or the third page or the fifth page will always be activity itself. And the second page will also give you the answers. So essentially what you could do is, after you do the activity, you can actually go and check what the answers are, and then know what you have done right and what you have not done, or done answered incorrectly. So this is the topic that we are covering, approximation and estimation today, and that's up on Moodle. Now, let me switch you back to the presentation and we'll do our discussion in terms of understanding what is estimation and what is approximation. Now, it is quite important sometimes to look at the meaning of the word. And if you know the meaning of the word, then it helps you to understand the topics quite well. Now, when I talk about estimation in mathematics, what is estimation? Now, in general, we come across the word estimating, estimate, a number of times. Sometimes you might get a plumber, or, you get a builder to your house and you say, what is the estimate for this particular job? So the estimate essentially refers to the process through which you go through by understanding the approximation or approximate cost or value of a particular activity or a job that you're asking a person to do. So when we look at estimation or estimate, in general, if I look at the English dictionary meaning of it, it basically is the meaning of this word is that calculation or judgment about a value of a particular job, quantity of product, or for example, service that you're going to ask somebody to get for you or do for you. And the outcome of this is going to be definite. So if you pay a plumber to fix something, he will give you an estimate that this is, if I need to fix this tap, or if I need to fix this and install this sink, this is the estimate for doing the job, and this is how much time it will take. So once the estimate is given and you have approved that cost, the cost is going to be the same. It will not be drastically different from what you have actually approved. So this is a term which is commonly used in day-to-day life, in business, in finance, in statistics, in everyday decision making. And sometimes what you do is you use estimation essentially to do activities. Now, one of the things you might also look at would be that if I'm traveling from my home to Trafford today, what is the estimated time it will take for me to travel if I take a car, if I take a tram, or if I go by bus? So what you're looking at is you're deciding on the estimate. That means how much time it is going to take for you to reach that destination. And then what you look at is you calculate that if I go by bus, it is going to take me 45 minutes. If I go by tram, it will probably take me 20 minutes, but I have to travel from my house to the nearest tram station, which is also a bit of travel time. And then you say, okay, if I take my car, probably it will take me 25 minutes, but it will be the most convenient because according to your estimate on time, cost, and quality in terms of how you go, you will see that car might be the best way to travel, because you're going from point to point. You're in control of how you're driving, how you're going, which route you're taking, and the third is you're not dependent on anybody. So here the estimate is the key word that you would normally look at when you want to take a decision, or essentially make a decision to say which will be the most optimum means of transport that I can take primarily to travel from my house to the Trafford Center. So when you look at estimation, it is, or estimate, it is an approximate calculation or value of the product or a quantity or service. And you're going to normally see that this is something that we use on a daily basis to make decisions in business, in finance, in statistics, in any sort of field that we work in. Now, what is estimation in mathematics? What is the reason why we want to study this as a topic in maths? Now, estimation in mathematics is a process through which we find out about the approximate value rather than the exact answer. So sometimes when you do calculations, when you are, say, for example, looking at building and engineering and certain types of jobs, say, for example, in nursing or in medicine, you would say, okay, if example, just as a vague example, if the doctor was going to tell you that you need to undergo surgery, and this could be a surgery to remove a tumor from your body. Now, the first question that you might ask is, how long will the operation be? What you are essentially asking the doctor is and then you might also ask certain questions. So here the question is, how long the operation be? What is the success rate of the operation? How long will it take me to recover, from the operation or surgery that I've had? So essentially, what you're asking by using the different words like long, how long will it take? What could be the recovery time? Is all you're asking is about the estimates around it, the success rate of the operation or the surgery. What you're asking the doctor is the estimate, because you want to mentally in your body, or you yourself and your family wants to decide whether this is something that you want to undertake or not. So essentially what you're looking at is estimating the success rate of the surgery, estimating the time it will take for the operation, estimating the time in which you would essentially recover from the surgery or the operation. And that is why it is an approximate value that you're trying to determine rather than an exact answer. The doctor in any case might not be able to say, okay, your surgery will take 2 hours and 14 minutes. There could be complications, there could be things which could happen quite quickly or delay things, and that is where the time cannot be given. So it's an approximate value rather than an exact time or an answer that you are actually seeking. And that is why estimation is very important when we look at doing calculations in maths. So sometimes in certain situations, it becomes unnecessary or impractical to look at predicting the exact times or time frames in which things can be done. And rather, what you do is you focus on what is called approximation. And that is what would essentially be the things that we are going to study in this particular topic. Now, estimation essentially helps us in checking or getting, or say, for example, getting things done quickly. It could be quicker calculations, it could be reasonable answers that you could get, it could be making informed decisions, but that is where the role of estimation comes in mathematics. Now, a simple answer is, you might go to a hawker and buy some vegetables, and you would say, okay, how much would a kg of mangoes cost? Now you'd say, okay, there'll be 10 pounds. But when he actually, puts the mangoes on the weighing scale, it might differ. The shape and the size and the weight of each of the mangoes will differ. So it might not come up to an approximate kg, but he will put 990 gram or maybe 1 kg and 10 grams, and he puts them in the weighing balance in such a way that you say, I only want a kg. So he'll give you an approximate weight around that kg, and the price would then accordingly change. So it might be 10 pounds and 50 penny because it's slightly over a kg, or it might be 9 pound and 10 penny because it's slightly under a kg, because of the shape and size of the mangoes that he's actually weighing on the weighing scale. So estimation, what I'm trying to get at is, what is estimation used for? Estimation is used for rounding off essentially figures or numbers in when you're doing calculations. That is the first reason that you use estimation for. The second reason that you're going to use estimation for is for calculating approximate values. That means if you want to find out that, it's not necessary that you go to the market for buying always. But sometimes if you're going to the market and you see something which is of your interest and you say, okay, how much of this quantity will cost? Or how much would this cost? You are basically asking about an estimate value of what this would cost if you want to buy it in this much quantity. So the second most important reason why estimation is used is you want to look at approximate value or finding out the approximate price of a particular quantity, product or service that you're buying. And the third reason why you would look at estimation would be to speed up calculations that you want to do. Sometimes you do it in your mind, sometimes you have to do it verbally, sometimes you have to do it from a point of view of just arriving at some values, like the example I gave you of traveling from your home to Trafford Center. If somebody is to ask you a question, how long does it take for you to travel from here to Trafford Center? Now, every time you can't say that it takes me 20 minutes. And then if you say 20 minutes, you're absolutely certain that every time you go, whether it's day, night, evening, morning, traffic, rain, you're going to take 20 minutes. You cannot be sure on that. So that is where you have to give an estimate that, okay, it roughly takes me, or approximately takes me 20, 25 minutes. So these are the reasons why you look at doing estimation. That means sometimes you give a appropriate answer to the nearest possible definite outcome, which is in the terms of time, 20, 25 minutes. It helps in checking the accuracy of your calculations sometimes when you do, and sometimes you use it in budgeting, in planning, and obviously, anything that you are looking at managing or paying for in terms of service when you're getting it done. And as I give you an example of plumbing or, something like that. Now, the other thing that we want to look at approximation. Now, what is approximation? Approximation refers to finding the nearest value that is close to the possible correct answer. That means it might not be the exact answer, but what you're trying to do is you are trying to approximate it to the nearest possible answer or value or true value essentially. So approximation in mathematics refers to finding a value that is close to but not exactly to the true value of the product. Now, give you an example. If you take, something across to the pawn shop and you say, okay, I want to pawn this watch because I want, I'm in urgent need of some money. So what will happen is when you take it to the pawn shop, the guy at the counter would essentially look at the condition of the watch, look at how new is it, what is the packaging, or what is available, guarantee, warranty. And then the person would say, okay, this new watch, if you were to buy, because he'll do some quick research on the website, and he'll say, assuming you are, pawning a Rolex watch, he'd say, okay, the new model of this particular watch is costing 7,000. But because your is a used model and it's not pristine, I think keeping in mind, I can see the year of manufacture, it's 2018. And this particular watch, by that time value, is going to be approximately, say 5,000 pounds. The new one is going to cost 7,000, and the used one that you're pawning in exchange for some money because you need urgent loan is going to be 5,000 pounds. So what he's going to do is he's going to say roundabout, I will be able to give you this amount of money considering its condition, its current market value, and obviously how long have you had it for. So in such cases, when calculations are done in order to make quick estimates or look at I would say nearest value, not a true value but a nearest value. In such cases you would see approximations are required to be done. Now, how are approximations done? Approximations are done by using what is called rounding off in the in mathematics. So you round it off to the nearest possible decimal. I'll explain with examples. Sometimes you do truncation. So, for example, you would say, okay, the course fees is 1,000 pounds and you want to pay it in 10 installments. So 1000 divided by 10 is 100 pounds a month. But assuming if somebody comes in and says, okay, can you offer me 12 installments? So the fees is 10,000 pounds, but the person wants to pay it in 12 months. So what you will do is if you divide 1000 by 12, you are going to get a value, because obviously they are looking at 12 months. So if you divide 1000 by 12, that will be 83 pounds and 83 pounds and 0.333333 pennies, right? So what I would want to do is, before I give this as an option to one of the students to say, okay, you can pay the fees, what I'm going to do is I'm going to truncate the value, and I'm going to say it is going to be 83 pounds and 33 pence, 12 installments for this course, right? Sometimes you have to divide a particular number or a value and you get the value in decibels, which is in points. So in such cases, you would use truncation. Now, you also use, when I say rounding off, if I were to say that, okay, it's 83 pounds and 33 pence, I will round it off to the nearest decibel. Because it is lesser than 0.5 or 50%, I would say the installment is going to be 83 pounds. So that is another reason why you look at approximation. And then sometimes you have to look at approximation because you want to give some sort of a figure or an exact figure to somebody. And in such cases, when we look at jobs or work which is related, for time and days, then in such cases you can't say, an example that I will give you is, if you are getting a new bathroom made in your house, the plumber and the builder comes in and say, okay, I will take 4.33 days. You will say, hang on, what do you mean by 4.33 days? So in such cases, the builder would come in and say, okay, it will take 4 to 5 days. Or he would say, okay, I will take four day and half a day just to finish it off, or polish it off, so that it is basically the half a day would be for the painting and you'd be able to use the bathroom from the next day. So in such cases, when you look at work, which is primarily approximate estimates of, you don't look at days, because at the end of the day, you would also have to cost it from a point that, okay, if the plumber or the builder works at 200 pounds a day, and if he says 4.33 days, you would need to find out the cost. Okay, what is 0.33? How many hours is he going to spend in the 8 hours that he's going to be working within the day in the toilet? So you normally would do an estimate and say, okay, is it going to be 4 days, 4.5 days, or 5 days? You'll say, okay, it will be 4.5 days, give or take here and there. And that is what also going to help you to calculate the value of service that you will pay him for. If he finishes the work in 4 days, you'll pay him for 4 days. If he finishes the work in 4.5 days, you'll pay him another half a day worth of wages, because he's worked for that half a day to complete the reconstruction of your bathroom in the house. But if he comes in and says, okay, I need to just do this and do that, in such cases you might not do approximation. In such cases you would do estimation, because you are asking him to give you an estimate of the price before he actually starts the work. Now if he said 4 to 5 days, and if it goes to 7 days, then you will question him that why is it that it has taken 7 days. You said 4 to 5 days, I'm only going to pay you for 4 or 5 days. So in such cases you use approximation. So looking at the definition of approximation and estimation, is it clear? Where do you approximate? Where do you use approximate value? And where do you use estimated value? Any questions on this? Okay. Now, when we look at approximation and estimation, there are 2-3 ways in which we need to be able to use this in the context of exams. One is understanding, which I've given, but now I want to use it from a context of exam and what kind of questions would come in the exam. Now, one of the first things that you want to differentiate is what is a number and what is a digit. Now, there are only 10 digits in the number system, 0 to 9, and they are then repeated again and again. So when I say digits, you would immediately recognize that digits refers to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because if I say 799, it is made up of digits, right? 799 is 799. That means it has got unit, tens, and hundreds as value. And these digits are organized in such a way that some values are pointing to hundreds, some are pointing to tens, and some are pointing to units. So when we say digits, it should click in your mind immediately. Digits means 0 to 9, 1, 2, 3, 4, 9, and these are digits. When I talk about numbers, numbers are made by combining digits. If I say 10,000, then 10,000 is made up of 1 and 4 zeros as digit, 1 and 0 as digit. If I say 999, it is made up of 9 using 3 times as a digit. If I say 697, this is a number, it is made up of 3 digits, 6, 9, and 7. Now, when we talk about numbers, it is important to understand what is the place of the number and what value does it signify when we place it in a position. Now, this is very important because if I take an example and I put it here just as an example, if you look at this table in particular, if I look at this table actually signifies what would be the place and the value of that number of the digit on in a number based system. So if I have this number, for example, which is this, I've just randomly picked up one particular number and I put some commas. So unit tens 100 and then 1 comma here. Now this tells me what, obviously I know that this is made up of digits 1 and 0, but what is the place and value of this digit when I look at individually each of them. So when I look at from the right hand side, the last number, which is 0, this is in units value. That means its value is single. Then it goes to tens. Then the third number is in the place is hundreds. Then you have 1,000. Then you have 10,000. You have 100,000. And if I were to put another number here, that will become million, right? So this is how you identify the value of the number, each digit depending on the place it is in the number. So I'll repeat. How do you decide the value of the number which has been given to you on the basis of the place where the digit is actually placed? So if I were to randomly give you a number, randomly, you would need to tell me what this number is. How would you decide what this number is? How would you pronounce? What would you say? So if I put a smaller number like this, you clearly know this is 100 because this is something that you come across every day. This is unit, tens, and 100, right? If I change 1 with 3, this will become 300. But if I put another 0, this becomes unit, tens, 100, 1,000. This is 3,000. But if I were to give you a big number, how would you decide what is this number? And the only way that you'll be able to decide the value of this number would be on the basis of the place the digits occupy. So first thing that I'm going to do is put some commas for every thousands, right? So you have unit, tens, 100, 1,000, 10,000, 100,000, million, 10 million, 100 million, billion, 10 billion, 100 billion, 1,000 billion. So this means this number is 5 trillion, 685 billion, 459 million, 625,123, right? So deciphering the place, assuming this was a currency, and deciphering or knowing the place of the digit in the number would allow you to understand its value. And that is why it is very important to understand how the numbers are written, where they are in the number in terms of its position, and what value does that position carry, which allows you to understand and read the value of that number. Is that okay? Is that understood? So if I were to take something small, just as an example, so if I put, say, just randomly some number, and I would say, let's look at what is the value of this number. So first thing that I'm going to do is go put some commas after 3, right? And then I will start to read. This is a table that allows me to understand this. So first is unit, tens, 100, 1,000, 10,000, 100,000, million, 10 million. So this value of the number is 23,547,452 pounds, assuming it was pounds. So this is the way that you look at understanding the numbers, by knowing that they are made up of digits, and the digits would essentially form the numbers. Then place and the value of the digit in the number will determine the overall value of how you recognize the number. Right? So place and value in the numbers. So if this is 3, what is the value of 3 in each of these numbers? Let's look at a small exercise. What is the value of 3 in this number? So this appears in units. The value of 3 is 3 units. What is the value here in this number for number 3? It appears in the location tens. So unit tens. So the value is 30. So 30 or tens. In this case, it is 324. So 3, you have unit, tens, 100. In this case, you have unit, tens, 100,000, 10,000, 100,000. So it is 345, 100,000 in terms of value. So 300,000. And what is the value here? So we again start unit, tens, 100,000, 10,000. So it is 30,000. So these are questions that you're going to get in the exam. At least 1 or 2 questions come in the paper. One is on estimation, one is the value or the place of the number. And if you know how to recognize the value of the number by knowing this table, you'll be able to confidently answer that question. Unit, tens, 100,000, 10,000, 100,000, million, 10 million, 100 million, billion. Then billion is 10 billion, 100 million. 1,000 billion is 1 trillion. So you need to know exactly the place of the value in numbers, and that would be one of the questions. Now, what we want to be able to also do is understand how numbers can be referred to as digits, right? So 6 is a 1-digit number because there's only 1 digit, 6. But if you look at 37, this is a 2-digit number because there are 2 digits making the number. Unit and tens, 37. This is 3-digit, this is 4-digit, and so on. So if I go back to this number, how many digit number is this? 1, 2, 3, 4, 5, 6, 7, 8-digit number, right? If I go to this is a 14, 3, 6, 9, 12, 13-digit number. So you need to be able to recognize how the numbers are being made and how many digits they have. So if I tell you how many digits is in this number 9732, any guesses? It's a how many digit number?
4 digits.
That's correct. It's a 4-digit number. Very good. So when we look at these kind of questions, there'll be one question that you will definitely get, and that would be to recognize the digit, the value, and the place of the number digit on the number system. Now, when we have numbers, we want to go back to the original topic of approximation and estimate. Now, how do we know numbers are greater than or lesser than? So there are 2 such symbols which are used in mathematics, and they basically define greater than and lesser than. Sometimes you will get a question in your paper which says compare 2 numbers or compare 2 types of numbers. It could be saying that, okay, this left side of the column has, different coins, 50 penny, 20 penny, 1 pound, 5 pound. On the right hand side, you have 10 penny, 20 penny, 20 penny, 20 penny, 5 penny, and 30 penny. Now, what the question would ask you to say is which side is greater in value. So how would you do that? You would need to know which side is more in terms of the value. So what you will do is you'll add 20 penny 3 times, 30 penny and 10 penny and 5 penny. That makes up 55 penny. But on the left hand side, you have a pound, 20 penny, 10 penny, whatever randomly I'm speaking. And that because it has more value, like 1 pound and 35 penny. So this side of the value would be greater. That means left side because it has more coins there. So in such cases, you would need to compare. If I am looking at comparison, you sometimes compare who's heavier. Your boy is heavier or your girl is heavier. Now you don't have an actual weighing machine that you can ask them to stand on. So what you then do is you look at them and their figure and the height, and you say, okay, no, I think the boy seems to be heavy because he's more massively built and he's taller than the girl. So you would basically make an estimate that, okay, basis the appearance and what he is wearing, I think the boy is heavier. So you would say the boy is heavier than the girl. So in situations wherein you have to do comparison, you're going to use greater than or lesser than sign, right? So if I were to compare two numbers and say which number is greater, 100,000 versus 99,999, you would obviously know the values and the digits, and you'd compare and you'd say, okay, 100,000 is greater than 99,999 in terms of number. But if I have to compare and say, okay, is 1 million greater or 999,000 greater than million? You would say no, 1 million, this number is lesser than 1 million. The other way of saying this would be 1 million is greater than 999,000. But the one way of saying is you could also say 999,000 is lesser than 1 million. So greater than and lesser than symbols are essentially used when you have to do comparisons amongst numbers. An approximate value you've got, and what you have to do is you have to compare the two approximate values to see which side is greater or which side is heavier or which side is bigger. And in such cases, you use more than or less than. Is that okay? Now, going back, so these are all tools that we use in estimation and approximation: more than and less than, the amount of digits in the number, the places in the number of what it determines as a value. They are all used in estimating and approximation, right? So if I were to say, how do you approximate and how do you estimate? You use comparison, greater than, less than. You use and understand what is the value of each of the digit in the places it carries. And you also look at the number of digits that are making up the number. And these, if you have a good understanding of, it will allow you to understand the topic of estimation and approximation. Is that okay? So now let's look at how do we do estimations. Now, before carrying out any calculations, what we say is it's a good idea to have a rough idea of what the answer you are going to expect, right? And this can be done by estimation. I'll give you an example here, not from the slide, but from otherwise. Like, for example, now spring is coming. And because the spring is coming, a lot of us are going to B&Q and we are looking at buying, I would say soil and a couple of other things that you want to plant or, improve in your garden. Now, you know the approximate size of your garden, whether it's 10 square meter or 14 square meter. What you're going to do is you're going to estimate how many bags of soil would you need to be able to put in your garden so that you can start to grow plants again because spring is coming. So here you're using the idea of approximation and estimation to buy certain things from B&Q. How much of, say, for example, some sort of weedicide you would need to make sure that it covers the garden and you're able to spray everything across and get rid of the weeds and other bits. So what you're going to say is one bottle is 1 liter, you have a half a liter bottle, you have 2 liter bottle. I think 2 liters is going to be enough because it says you need to dilute this into 3 buckets of water and we'll be able to spray 3 buckets of water in our garden. Here, what is the process you're using? The process you're using is estimation and approximation. So when you look at buying products, say for example, and going back to the example which is given on the slide, assuming you're going for a weekly shop today, right? And you've got 50 pounds in your weekly pocket and you say, okay, I need to buy a lot of things, but my budget is only 50 pounds. So what you're going to do is you're going to quickly estimate what are the main things you're going to buy. So I have to buy bread, milk, and eggs. Definite, I can't do without them. I have to buy onions and potatoes and tomatoes. Now, these are bare minimum that you have to get. So what you're going to do is first and foremost, buy these items. And then you'll say, okay, this one was 2 pounds, this one was 1 pound and 30, this pound was this. And then you're mentally doing the calculation as you're wheeling your trolley in Tesco or Asda to say, okay, I think I've bought something worth about 25, 30 pounds. I've still got 25 pounds to go. So what else can I buy? Then you look at other items and you're mentally calculating in your mind that how much estimated spend I've got in terms of the goods in my trolley. And that is where you would use estimation and approximation on a daily basis in our day-to-day life. So I've gone in for a weekly shop. That is where I'm using it. So I'm actually using a live example. So if I get magazine or newspaper today, a loaf of bread, chocolates, some bananas, this and that, and what you're doing is, okay, I've got this for approximately £2, £4, 6 and 3, 9. I've got 12. So I've still got £34 left or £36 left to buy. And that is why you want to quickly do a roundup and estimate of how much is still available for you to be able to spend. And that is the reason why you look at estimations. You're not looking at an exact answer. The exact answer in terms of how much you've spent or what is the weekly shop cost you, your weekly trolley or the weekly shop has cost you, well, you'll actually find out in any case when you go up to the till. And the till, when the person tills everything out, they'll say, okay, your bill is £48 and 32 pennies. Would you want to pay cash or card? Then you know the exact value then. But that would tell you very clearly in your mind that, okay, I've done my calculations well, I've managed everything and I've still saved a couple of, pounds, but I was correct that I bought more or less everything that I wanted to do in my weekly shop. So that is where the estimation things runs, and you'll feel quite happy that, okay, I've managed to get everything within the budget that I had when I went to the weekly shop. Now, when you look at estimations, estimation is when you're looking at finding the exact answer. Approximation is you're not interested in the exact answer, you're interested in the roundabout figure or the answer. But estimation is you want to find the exact answer. Reason, you want to get a bathroom made in the house, as I gave you an example earlier. You cannot say that when you call the builder in and the builder will give you an estimate and say, okay, it'll cost you 2,000 to 2,100. But you do not want that answer to become 4,000 and 4,500. Because you're budgeted for some money and you're doing it against a particular budget. Now, if he says that, okay, the bathroom, when you go to B&Q and you say, okay, I want to get this new bathroom installed, or you want to go to Ren Kitchen and you say new kitchen installed, they'll say, okay, this kitchen is 3,500 delivered and installed. You want the exact estimate because you're going to pay the money, right? And you're up against the budget. But you're not going to be tolerating that, when you advertise, you say 3,500, but now it is delivered and you're asking me 4,200 something. That is not correct. So you'll be surprised. So in such cases, when you look at exact value and you want to look at exact value in terms of money that you have to pay, in this case, as an example of kitchen or bathroom, you would not do approximation. You would basically look at exact value because you're budgeting for it and you're asking him to come and do the job in this value. If it was a repair job that one of the taps is broken or if there is a leak, then obviously you'll call a plumber or a person who'd come in and give you an estimate that to fix this, it'll cost you between 100 to 110 pounds, depending on the value of the part or what I need to replace. But that is still tolerable. But if somebody comes in and says, okay, I'll install your bathroom in 2,000 pounds, and later on you find out he's asking you 2,600 pounds, you'll say, no, you gave me an estimate and the estimate was 2,000. How has it reached 2,600? Because there was an exact value given, you would not tolerate that as a answer from the builder. So estimating in terms of mathematics is really done when you want to know the exact value or the exact answer to that question or that problem, right? And that would be done by using, again, the same three things that we've used, which is, when I spoke about approximation, we talked about how approximations can be done. One is rounding off. Second is looking at approximation in terms of truncation. And the third is in terms of, looking at rounding off to nearest decibel. So if the person said that, if I look at an example here, it says calculate 312 minus 97 divided by 9.8. Now, if you had the scientific calculator, what you'll do is do 312 minus 97, and that value, 312 minus 97, that value is 215. 215 divided by 9.8. Now that value comes out to be 21.93877, so on and so forth. Now, if you were to round it off, 21.93, you would round it off to the nearest value. But because it is more than 0.5, you will round it off to the nearest number, which is 21.93 will become 22, essentially. But if I were to truncate it, And if I were to say that, okay, I want to know the exact value to the exact decimal, then what I would do is the number 21.93877, I will round it off, or basically truncate it in this case to 21.932 decimals. Because you can only give 93 pennies. For example, if it was money, you can only give 93 pennies, but you cannot give 938 pennies or 938 9,387, which is decimals. It won't be possible. You don't have shillings now. Shillings were there, which were smaller than pennies, but we don't have them now. So the smallest money currency is penny. So yeah, if I have to give something, I can give to 21 pounds and 93 pennies, but I can't give 938 pennies. So in such cases, you would use the principle of truncation, and you would truncate the decimal value to the nearest two decimals, which is 93. And instead of 93877, you will truncate it down to 93. So in estimating, you can estimate by rounding off. If I were to say, okay, sometimes you go and buy wood for the log burner, and the log burner guy says, okay, you purchased this much wood, this is 91.60 penny. You'll say, okay, I'll give, if it is 98.60 penny, you'll say, okay, here we go, I'll give you 100 pounds, keep the change. And that is rounding off. But when I say truncating, 91.58, you would say, okay, 91.6 pennies. That means 91 pounds and 60 pennies. And that would be truncation. So in such cases, when you use estimation to find out the exact value or the exact value of this particular transaction, then in such cases you either use rounding off or you use truncation. Rounding off would mean if it is coming out to be 21.93, this particular equation, I can round it off to 20, to say, okay, can I pay you 20 for this? The person would say yes or no. But if I had to truncate it, it would come out to be 21.93, which would mean that I will truncate it to 21 pounds and 93 pennies for the person to be able to pay me. And in such cases, when sometimes in mathematical questions, if you say that truncate this answer and provide your answer to the two decimal value. So what you will have to do is 3112 minus 97 divided by 9.8. If it says provide answer to the nearest two decimal value, then you will say 21.84. But if it says round it off, you will to the nearest number, then rounding off will happen. Now, if you see 21.84, is it nearer to 20 or is it nearer to 30? It is nearer to 20. So you'll round it off to 20. If I take another example, just for the purposes of understanding, if I take another example, say 20 minus 17 divided by, or 200 minus, say, 153 and divided by 2, right? How do I do this? So if I put equal to here, 200 minus 153 is 47. So the answer is 47 divided by 2. And if I have to now find out two things, now my question is, this is a fraction. 47 by 22 is also an answer. 47 by 2 is also an answer, which is a fraction. But if I say, can you represent this fraction now to the nearest number? So what I will need to do is divide 47 by 2, and that would be equal to, if I need to say nearest number, that means I'm rounding off. Rounding off, sorry. Rounding off. Okay, and then when I say nearest to, or say near to two decimal places, this is the other way of asking. So in this case, what I would do is, when I say rounding off, if I divide 47 by 2 is 23.5. So if I need to round off, what will happen is, if I need to round off, is 23 closer to 20 or is it closer to 30? So depending on it is closer to 20, the answer here in this case would be rounding off to 20. And if I say nearest to the 2 decimal, so obviously in this case, the answer is 23.50. Because 47 divided by 2 is 23.50, and because the answer is required to the 2 decimals, so I have to have this exact number put in, which is 23.50. Right? Now, if I were to, this is rounding off. If I was to look at, what is called approximation of 23.50, what would be the approximation here? If I had to round it off and apply approximation, then this number would become 24 because it is 0.5. So 0.5 or anything value in terms of decimals greater than 0.5, 0.6, 0.7, they will all round it up to the next near whole number. So in this case, it will become 24. But if this was 23.35, then when I had to round it off with approximation, this would have become 23 because the value is less than 50. So if it is more than 0.5 or more than 50, you round it off to the next whole number. If it is less than 0.5 or 50, then you round it off to the nearest lowest whole number. So that will become 23. If it was 23.57 example, then this would become 24. Is that okay? So when we look at estimation and approximation, the key difference between the two is that when we look at estimation, we are looking at exact value. When we look at approximation, we are looking at the nearest possible value which the calculation or your, for example, the number would or digits would arrive at. So the difference between estimation and approximation is that when you look at estimation, you're trying to find the approximate exact value, and approximation is when you're trying to find the approximate value number or value that can be to the closest number. Estimation is less precise, approximation is more precise because it is based on the actual event. And when you look at an example of that, in such cases, estimation, you would always round it off, truncate, or give it to certain nearest whole number if it was a fraction. But in the other case, you will basically round it off or truncate it to the nearest possible value which is being asked for. And that is the key thing that you need to understand when we talk about these two concepts of estimation and approximation. So there are some examples that I've given here, estimating calculations. And estimating calculations, for example, you are running or swimming, or you are essentially doing certain laps. How much time would it take for you to approximately run this much distance or do these many laps when you were swimming? And that is where you would be looking at the concept of estimation and approximations. So this brings us to the end. Any questions on today's session? So in the Moodle, if I take you, there are 1 or 2 exercises that I put for you to look at. If you look at this is a particular exercise that I put as an activity for you to do to understand what we've covered today. So in this case, the value of 3s that could be determined, the number of digits, and less than and more than, and then also tell whether this is number greater than or lesser than, to basically just cover some of the concepts that I mentioned today in the discussion. This is one particular activity that you can do to test what you have learned in terms of our discussion today. So there's another one that I've given. The first page has certain questions and then the answers which are on the second page that you can check whether you're able to understand this and do it correctly. So in this correct, you have to apply the symbol whether 501,789 is greater than or lesser than 99,897. So this is great. This number is greater than this number. So when you apply, you can also go back and obviously check the answers which are given at the bottom in the second page. So these are 2 particular exercises that I've asked you to do. Now, if you decide that you don't want to manually check your answers and obviously send it for checking to me. Then there's a Word document also given for this particular task here, which is this task, the 7-page task or 5-page task. This is also I've uploaded here as a Word document. And what you could do is download the Word document and fill it up and send it back. But the answers have also been provided just in case for you to, go ahead and confirm that you've understood this particular topic. Okay. So any final thoughts or questions on this?
Yeah, hello.
Yes, hi.
Thank you so much for your time. I'm just starting, so I don't really understand very well. At least I know as I'm going gradually, I will really understand.
Absolutely fine. No worries. This is the second session, so you haven't missed much. There is the first session, which was basically about numbers, positive and negative numbers. It's not very difficult to understand, and that you should be able to, go through with this bit here. If I just collapse this, it was just talking about positive and negative numbers. So this is the initial presentation that you can look at, and that would allow you to understand the first session. Okay.
Okay, like this one now, that positive numbers.
Yes.
You can go back, please. Yeah.
So this one, I would suggest that you go through this particular presentation at your end. I'm just
Okay.
going, this particular presentation, which is available for positive and negative numbers, and that one you can watch. I would give me 1 second. 1 second. Let me put this presentation on. Just 1 second. I'll show you. So this presentation for last week, I put up here the first document.
Okay.
When you click on this, it'll show you the presentation for what it was covered. Very simple, how do you decipher a number, whether it's positive or negative? So you put a minus sign, and sometimes you would see where the positive and negative numbers are used. If the temperature is -2, that means it has fallen below 0. That is why it is a negative number. So -2 is cold, or is +2 more cold? -2 is more cold. So this particular presentation, actually, when we look at numbers, when do we denote them as positive and when do we say they are negative, is used in different situations to calculate temperature, altitude, money, historical records. So when we say BC, before Christ, this event happened before 2024. So that means you're going back into the time, and that is why it is negative. When I say minus temperatures, it is negative. When I say that you owe me 50 pounds, that means you are in 50 pounds. When you look at your bank account and you have an overdraft limit, and if it shows you minus 500, that means you're overdrawn. So minus 500 means that you owe the bank 500 pounds, but it is given to you as a temporary limit from your overdrawn limit. So minus and positive, basically positive and negative numbers was explained in the first, session, and it was primarily
this one, I guess you just asked now.
This is the one I've uploaded here. This is where I've uploaded the presentation here. You can look at.
Okay. I will look at them later.
No worries. Okay, so
thank you so much.
So tomorrow, the same time, we'll have this session, 10:30, and tomorrow we'll be looking at covering the next, session, which will cover expressions.
So I've told the lady that I can't do Sundays because Sunday I'm in church in the morning.
All right.
She told me she will send me the recorded one on Monday.
To you, yeah, that's fine, no problem.
I
will post the recording, into the group just after
the
this.
Group chat.
Yeah. Group.
Okay. Thank you so much. Thank you, Mr. Ajan. Thank you.
Take care.
Bye-bye. Enjoy your weekend. Thank you. So we have a class next week Saturday.
No, you'll have a class tomorrow, but you'll not be able to join. Understand? You will get a copy of the recording. So the classes for maths and English is 9 a.m. to 10 a.m. on Saturday and Sunday, and maths is 10:30.
I missed the English class today. I didn't get that. I missed that one then.
Then English, if you are in the English group and also in the maths group.
I am on both.
Yeah, so I pasted the message before I started the session at 9 o'clock.
Because I was driving coming to uni. I'm here.
Maybe.
Yeah.
So 9 to 10 is English, fixed time,
English.
9 to 10 every weekend, Saturday, Sunday. One day we do reading, one day we do writing. And then 10:30 to 11:30 is maths. Every Saturday,
Okay.
Sunday.
Okay. So the one this 9 o'clock one, how am I going to get it? The English one
I've
that
already
you
put
did
the
this
recording into the chat. If
into
you
the
look at it.
chat.
Yeah, yeah.
Okay. Okay.
Okay.
Thank you so much.
No
Thank
worries.
you. Bye-bye.
Thank you.
Bye.
Bye. Bye.